Thanks, Margaret. So anyways, like I said, I'm Jerry Carrata, and I'm fortunate to get to moderate this next section on using TensorFlow Lite to expand our machine learning on both mobile and edge devices. We have a couple of presentations on this. Our first one will be done by Margaret. So let me just introduce her. You have seen Margaret doing all this management and things of this behind the scenes, but she's also a organizer of one of the largest communities, which is GDG Seattle, which hosts a lot of events throughout the year, which we mentioned earlier. In addition to that, she's an accomplished author. She has written many articles on machine learning development, including a recently published series of articles on how to use TensorFlow Lite on your phone to create anime versions of selfies. It's really cool, and I suggest you all check out the Medium article and check out her code. But even as busy as she is, Margaret is constantly helping other people. And to help us today, Margaret is going to go over TFLite and its awesome tools and community that will make your TFLite experience enjoyable and fun. And with that, I'll let Margaret take it away.
Great. Thank you so much, Jerry, for the introduction. Like Jerry said, we are part of the Google Developer Experts GDE, Machine Learning GDE community together. So we've worked with each other. And today, I am very excited to share with you about TensorFlow Lite. So I will discuss about what is TensorFlow Lite, why we need it, and mostly focus on how to use TensorFlow Lite. And then I will spend some time talking about the community, the awesome community. With TensorFlow 2.0, the whole model saving has been standardized into the saved model format. You can still save as a Keras model, but we recommend you use save the model, which you can deploy to clouds, web, mobile, IoT, microcontroller, and edge TPU. So TensorFlow Lite is a framework with a set of tools for deploying machine learning to mobile and embedded. Unlike earlier when you heard about some talks on TensorFlow JS, JS, it's also a language you can use to write your models, right? But TFLite, it's a framework of tools to help you to deploy. It's not something you use to write your machine learning training code. And there are many components. They are the key components. One is a converter for converting to the .TFLite model format, and then the interpreter that you can use to run the inference. And then there's the TensorFlow Lite ops, and then also interface to hardware accelerations. In addition, there are also some other features and tools in addition to these four main components that I mentioned. So why do we need TensorFlow Lite? So when we run machine learning model on device, we get the benefit of access to more data, faster user interaction, and preserve privacy. But there also comes the unique constraints of less compute power, limited memory, battery consumption, and you have to worry about the model size and inference speed. So TensorFlow Lite was created to help deploy models to mobile and edge devices in order to work with all these constraints that I just mentioned. So today, there are more than 4 billion devices and more than 1,000 plus apps in production running with TensorFlow Lite. And how do we use TensorFlow Lite? Well, there are these beginner getting started topics, and there's also advanced topics. So to get started, we talk about how do you save the model and do the model conversion. And also for people who are not so familiar with machine learning, there's TensorFlow Lite Model Maker and Metadata and CodeGen, and also the model ML model binding Android Studio also helps with like using the TFLite model in Android. So these are the beginner topics. Some more advanced topics will be how can you reduce model size with quantization and pruning, and how do you speed up the inference with GPU delegate using Android neural network API? How do you do benchmarking or profiling? So today, my goal is to more help you get started, as well as talk about some additional resources that comes from the community. So first, let's take a look at a very simple example, end-to-end process, going from training a model with tf.keras and convert that model to TFLite, and then run that model on Android. Very simple. So from this diagram, you will see that when you train the tf.keras, you have the option of using the keras sequential, functional, or model subclassing. And when you convert, you can use either Python code or you can use command line. And then here's all the steps of how to run it on Android, which I will go over the details later. So this first example is very simple. We use MNIST data. For those of you who are not familiar with machine learning, the MNIST data is what people will use for the hello world, like 60,000 training data set, 10,000 test data set, and 28 by 28 grayscale images with 10 classes, ranging from 0 to 9. And we can also use it for benchmarking machine learning algorithms. I have included the Colab here for writing the training code. You import the data, you define the model architecture, you train the model, and then we save and do the conversion. And in this particular example, we're saving as a keras model format and before we do the conversion. So once you write the code, you can call model.summary to show the model architecture. And the reason why I'm showing the model architecture is like a lot of times when you're working with like the conversion, you need to know, or even the model implementation, you need to know kind of your input shape, right? You have a data input to the model and then also the output. To visualize the model, you can use visualization tools such as TensorBoard. I use Netron. This is like an open source tool that once you install it, you just drag and drop the TFLite model into Netron, and then you will see the model visually. So later on, I will talk about the metadata, which is a new TensorFlow Lite tool. It will also allow you to inspect the model. So once you train the model, it's just simple examples. I didn't really show the training code there, but once you train it, and you can save the model, and you can save it to either save the model or keras model. In TensorFlow 2.0, the saving methods actually will default to the save the model format, not the keras model format. The save the model format is recommended. When do you use which? Especially if you are sharing a pre-trained model on TensorFlow Hub, for example, you definitely need to use the save the model format. And it's also useful if you don't know the deploy target. But let's say, in this case, I'm just writing a very simple example with MNIST. I know what my deployment target is to Android. I'm writing the training code, I'm saving it, and I'm converting it. So I just use keras. And I'm showing you the example where we have two options to do the model conversion. You can either use command line here, or you can use the Python code, which is recommended. Again, when you try to save, you can do save the model or keras model. So the command line method will be helpful. Like, for example, if somebody else has trained the model and gave you the model, so all you have is some model format, like save the model or Keras model, then you will run the command line to convert that. But the Python code, writing the Python code to do the conversion is recommended. And here is a very simple example that you create a converter and you set the quantization to be true, and then you will convert the model. And then after that, you can try, say, if you're in Colab, you create the actual TFLite model file, and then you can download the model files. So for those of you who have actually worked with the TFLite for a long time, you probably remember a couple years ago trying to do a conversion was not as simple, with just a few lines of code. And back then it was like really complicated. So now you have converted your model and to the TFLite format. Before you deploy it and after you convert, it's a really good practice to try to validate the result and make sure that the conversion process didn't really mess up your model. And you can look at the TensorFlow inference and also the TensorFlow Lite inference, and then compare the results. So now that we have a TFLite model, here's how we will implement it on Android. And I know not all of you are Android devs, but I'm still going to go over the steps just to show you how complex it is. So manually, you have to do a lot of manual work, right? You have to put the model under the assets folder, update the dependency, the input, etc., etc. So dependency, we have to come here. In Android Studio, we have to manually create an assets folder, put the TFLite model there, and then we will go to the build.gradle to manually set a bunch of dependencies to TensorFlow Lite, or like if you work with metadata, you will set all those dependencies, and also for example, set to say not compress a file if it's a TFLite format. And if we have an input image, in this case, if we're working with MNIST data, the digits, when you have the image that captured either by drawing on canvas from a custom view, or getting an image from the photos gallery, or getting an image from a third-party camera, or live frame from, say, your camera API, right? After that, you have to make sure, earlier I talked about the model is trained with 28 by 28. You have to make sure your input image is like that. And also depending on what kind of model we're talking about, if it's Inception or MobileNet, etc., you have to match up the input shape. And then there's image preprocessing to convert from a bitmap to byte buffer, because that's what TFLite works with. You have to also normalize the pixel value to be a certain range, just like what you do in the model training. And you need to also convert from color to grayscale, because when you use the camera or the input methods, as I mentioned earlier, they have other several options that all have images in color. And then because the model was trained in grayscale, you have to do that conversion. And then to run the inference, you have to load the model, the TFLite model that's created under the assets folder. And you have to also load create the interpreter. You then run the inference, and which will give you some sort of results. And it's like an array of probabilities, each correspond to a category. In this case, we have 10 categories, going from 0, 1, 2, 3, etc., to 9. And then you'll find the category with the highest probability, and then output the result to the UI. So this is the example code here. It's a digital recognizer where I will draw with my finger, like a number 8. And this is a custom canvas. And then you click on the classify button, and then the model will predict it's an A. So I just walked you through an example with MNIST, which is a toy example. The model architecture is super simple. The data set is super simple. So training with TF.Keras is fairly easy. I didn't even include the code earlier because it's just a few lines of code. Model conversion to TFLite was also fairly easy, as I showed you earlier, either via command line or Python code. Either way, it's just a few lines of code. But the Android implementation was a lot of work. You don't have to understand Android to understand what I explained to you earlier with all those manual steps of placing file in there, dependency updates, and worrying about image preprocessing, input tensor shape, if it's a color or grayscale, post-processing, etc., right? Anyway, so I have included my blog post there for you to read in more details. So how can we make it better? What I just described to you, especially the Android implementation, was very complicated. At TensorFlow World last year, there were quite a few new features announced, like the TensorFlow Lite support library, the metadata, the model maker. Later on, I will also talk about the ML model binding. And all of these will make it much easier to work with TensorFlow Lite. So I will talk about the metadata and the CodeGen briefly. You will use pip install TFLite dash support, this library. It will provide you with two functionality. One is metadata, which this will contain information about the model. I didn't include the details here, but you can run it through a command line script. Currently, the metadata examples, if you go to the official TensorFlow.org documentation, you will see the script for image classification. I think it's not posted yet there, but what's available or supported, it's also cell transfer supports the metadata. And later on, I will talk about a example that I'm working on called a selfie to animate. So we can also use metadata for GANs or image to image translation. So what it does is that you either run it through command line or maybe in Colab. The tool will help to add a bunch of information about your model, like for example, the input shape and what the model is about. At the same time, it will enable the CodeGen, which is the automatic code generation of Android wrapper for using of the TFLite model. So earlier, I mentioned to you a lot of really manual process, and all of that will be taken care of by CodeGen. So you don't have to do a lot of that manual work. So I wrote a two-part tutorial to demonstrate those two features. To demonstrate the CodeGen and the metadata and CodeGen, but through the ML model binding from Android Studio. But the first part is actually using another tool called the TensorFlow Lite model maker. So what it does is that when you do the machine learning training, you actually have to worry a lot about the data loading and pre-processing, which is really hard in machine learning. When I showed you the toy example of MNIST, you don't have to worry about it because that toy example comes with part of Keras, right? It's just one line. You can load the data. Or when you use, say, TensorFlow 2.0's TFDS, there's also ready-made data. And if you use Kaggle, the data is, you can also find a lot of very nice, clean data, right? But in the real world, when you work on your own machine learning model problems that you may spend a lot of time in the data pre-processing part. So the nice thing about the TensorFlow Lite model maker is that you don't have to worry about the data processing part. All you have to do is just point to your folder of images or files that you have, right? So the input can be TFDS, can be Kaggle, can be something you download from the internet, or the pictures of your cat that you took, right? All you have to do is point to those folders, and then just with a few lines of code there, and you can create a model currently supporting image classification or text classification, and it's default to efficient net, but you can also change it to be MobileNet, ResNet, or a particular model that you find on TF So it's quite versatile. And another nice thing about this TensorFlow Lite model maker is if you use the model maker to create a model, by default, the metadata is already part of that TFLite model that gets generated, right? So earlier I mentioned to you to get the metadata added to the TFLite model, you can either run a Python script or you can write some code in Colab to do it. Either way, you have to write a bunch of code, quite frankly, very boilerplate code to add that metadata. But TensorFlow Lite model maker does that all for you. So once you have a TFLite model with that metadata, and when you're in Enter Studio, all you have to do is go through some path to say, import my model. And once you import that TFLite model with metadata, all the manual step that I mentioned to you of placing the model manually under some folder, you don't have to do it anymore. That manually going to build.gradle to update the dependency, you don't have to do it anymore. And to write all the code to load the TFLite model and run the inference, you don't have to do anything. Like, you don't have to do much to use that TFLite model other than just a few minutes going through the menu path and import and done. And it will also give you some code snippets where you can copy and paste and directly use in your model. So now I'm going to switch gear to be talking about community. And so as I said, 2019, the model conversion got much better last year, but a bunch of improvements was made, but we don't have too many end-to-end TensorFlow Lite sample just yet. But now, fast forward to now, we actually have a dedicated repo under the ML GDE on ML GDE org on GitHub. You can find that there's a list of sample app ideas and projects that you can help with. And I only took a screenshot of the top part of it, of the project ideas and help needed. But on that GitHub, you actually will find like in progress and completed end-to-end tutorials, and you can help with the existing proposed ideas, or you can propose new ideas, and you can help with creating the model, converting the model. You can help with writing iOS, Android, or implementing the model, say, on an edge device. And I want to talk briefly about Selfie to Animate, which is the first of the series of end-to-end TensorFlow Lite tutorials I just mentioned. And this was a collaboration, me collaborating with another machine learning GDE Sanyak and Khan Levitt from TensorFlow Lite team. And this is a state of art. If you look at this link that I put here, you will see that the repo has like 4,000 stars on the model, the paper repo. and its image-to-image translation was GANs. However, even though it's state-of-art and it's new, the model training code was written in TensorFlow 1. So this end-to-end tutorial actually gave the example of how to save the model in TensorFlow 1.0 and then do the model conversion in TensorFlow 2.x, and then run the inference in Python, as I said earlier, and then add the metadata and run the benchmarking tool, and then finally implement it on Android. So I will put a link of the Selfie to Animate project so that you can check out the details here. And I also want to talk about, my talk title is called Awesome TFLite. There's this awesome list that I put together with all the TensorFlow Lite models, apps, tutorials, and learning resources. And you can check it out. The machine learning GDE and Android community really helped out with this repo a lot. And we also have support from the broader community. And also thanks to the TensorFlow Lite team for their help with this. So definitely check out this. And a few things that I did not mention in this talk because I try to compress it. If you go to the Awesome TFLite repo, you will also find resources to things such as ML Kit. You can try implement your model, TFLite model with like media pipe, with third-party SDKs, for example, Fritz.ai, and just a whole lot more like books and the videos, etc. Some additional resources before I close my talk today. And I want to just give a shout out to Machine Learning GDE Sanyak Paul. He has this adventure in TFLite repo, and where he goes in depth to talk about quantization, saving and converting the models. And just today, GDG Kokada, Hoi Lam from Google also gave an excellent talk on Android ML. I encourage you to check that out. I still need to watch it, but I'm sure he'll be talking about all the new features with Android ML, including how to use Firebase and ML Kit, etc. And then a blog post by Khan Levit called "What's New in TensorFlow Lite" from the TensorFlow Dev Summit 2020. So he will also go in depth talking about a lot of the new TensorFlow Lite features from this year. So thank you everyone for listening to my talk, and please keep in touch. Follow me on Twitter, Medium, and GitHub to learn more about deep learning, TensorFlow, and on-device machine learning.
Okay, Margaret, thank you. Thank you very much. Let's see, a couple of questions here if you have a moment. The model maker sounds like a really cool piece of code. With it, how long, if somebody knows what they're doing already in Android, would you say it takes them to get like their first couple of models up and going?
That is an excellent question. In fact, somebody has asked me that question. Android GDE asked me a question. An Android expert asked me that question. And here's my answer. There's also this teachable machine. I think earlier might have got mentioned in earlier talks. So I want to compare and contrast those two. With the model maker, I will say if you don't know machine learning, it is still a bit challenging, in particular if you don't know Python that well, right? But if you know Python very well and you're taking some beginner machine learning classes, like you have some general idea of deep learning, image classification or text classification, it's very, very easy. But if you don't know Python, you have no clue about machine learning at all, then I think it's challenging. Then I would recommend you to use more of the tools that's more like web interface, drag and drop, like teachable machine, or there's another thing I didn't mention in my talk, but I usually mention in my previous talk, which is called the Edge. What is it called? The new Vision Edge as part of the ML kit or the Google Cloud. So I think it's Vision Edge.
Okay.
A tool that I'll find the link and share with you.
Yeah.
So share with everybody. So basically use this. People who don't know machine learning at all, it's better to just use the web interface, drag and drop.
Are you seeing a lot of, I know you specialize in Android and things like that. Do you see a lot of Android developers trying to build machine learning into their applications?
I think so. Again, I think I'm going to add to my, later on, I'll add a link to my slides, is that, so there's this TensorFlow.org. If you go to TensorFlow.org, look for the community tab. So there are different communities, right? There's TensorFlow JS, there's documentation, different one. So there's this community called the TFLite, right? So I'm part of that community, so I will see the questions that comes in. People will ask TFLite questions, right? And from what I've seen last year versus now, I see so many more questions about.
Oh, that's great.
About how do I do XYZ on Android? How do I do XYZ model on Android? Like ranging from people who know machine learning, who don't know a whole lot about mobile, or just mobile developers. They want to put something on a TFLite model on Android.
Okay. We do have one question that just came in. Somebody asked, let's see, Greg here, is MediaPipe working well now in Android? I don't know what MediaPipe is.
So I will take that question. If you follow me on Medium, you will see one of the articles I wrote about is getting started with MediaPipe on Android. When you say working well, I will say MediaPipe works pretty well on Android. Like if you go to the MediaPipe GitHub, you look at their examples, they work extremely well. In fact, some of the complex model training in MLKit under the hood is actually powered by MediaPipe. And MediaPipe is excellent for you to work with things like multi-hand tracking, like really heavy-duty kind of complex models. But if your question is it easy to get started for Android devs? I will say not so much, because just read my blog post, because I don't think it's that Android dev friendly to get started. But does it work well on Android? Yes, it works very well on Android.
Okay, great. One other thing I guess we probably should mention is you're, kind of Android specific, but most of this still works in the iOS community too. Is that not correct?
That's an excellent point. Yes, because my talk, I talk a lot about Android. I will say TFLite in general, like if you create a TFLite model, a lot of the process I mentioned should work with iOS. However, not everything. For example, the ML model binding, the thing that I mentioned, you go to Android Studio, you just click a button to say import my model.
Right.
That only works with Android at the moment.
Okay.
So yeah, there are certain things only work with, some of the tools only work with the Android, but TFLite in general, the model format in general, like yes, it worked with iOS and it worked with Edge TPU, which the next talk is about.
Right. So it sounds like maybe the iOS side is a little in trail, and I know the Edge one is a little more scriptish than, let's say,
yes, I will
toolish.
say, if you look at my example, actually I didn't include a whole lot of examples, but if you go to Awesome TFLite to look at examples or the official examples, you'll tend to see there's a lot of like image examples. We're still catching up with the text examples.
Yeah, okay.
So it's kind of like that. We might be catching up a bit with the iOS part, but I will say right now, the TensorFlow Lite team has made a lot of progress in that area.
Okay, great. let's see here. I don't see any other questions. I guess I would suggest everybody go and take a look at Margaret's awesome TFLite repo. I've looked at it. I don't claim to be an Android developer by any stretch of the imagination. I've done some, but not a lot. But it's helped me, because I come from a Python background, be able to move things over and to understand some of the little gotchas that you have when you work these small systems, such as, dealing with memory and that sort of thing, and that you have to think about maybe different than, on a small phone device or even smaller. Okay. Let's see, I guess thanks, Margaret. Do you have anything else? I guess that's it then? Okay.